All right, mathletes, so let's talk about section 5.5, which we're looking at factoring the GCF, the greatest common factor. And before we do so, let's make sure we have some vocabulary, because just like in class, it's always important to start with the vocabulary so that we understand what it is that we're doing. So let's start with example 1 actually, and we're going to go over this in class, but you could read over it. So notice here we have 5 for number 1. I'm down here. We have 5 times the quantity x minus 7. So whatever is being multiplied, as you're going to read in our definitions up here, whatever is being multiplied, those are called our factors. So that 5 is one factor, and the x minus 7, that's our second factor, because these are the two things that are being multiplied. Once you actually do that multiplication, right after you distribute, that is your product once you actually do the multiplication. All right. So again, you're going to fill out the rest of these using that same idea. So here we have a factor, 3x and x plus 9. Those are our factors. And the product is the final result. All right. So just some language, because we're going to use these words a lot. Factors and product. So just a little reminder there. So once we get into factoring polynomials, the most important thing to always do first, even on Sunday, is to factor out the greatest common factor, all right, which we are going to refer to as our GCF, our greatest common factor. And essentially, we're asking ourselves, what is the largest integer and the highest degree of each variable that will divide evenly into each term of the polynomial. All right. So what does that mean? Let's take example number 1. Let's start with our product. When I look at 5x and negative 35 minus 35, you're asking yourself, what's the biggest number that they have in common? Well, it's a 5, right? So that 5 is our greatest common factor. So we're going to look at some examples directly related to that idea. All right, so when we discuss this word, when we talk about factoring, what I want you to realize is this is just the reverse process of multiplication, right? So essentially we're going backwards, kind of like dividing, right? So I did this example for you. So let's talk about this one right here, all right, the second example. All right, so notice we have 2 terms, and the question is, all right, let's start with the number, the coefficients. So I have 3 and 27. You're asking yourself, what's the biggest number that I could divide into 3 and 27? What's the greatest factor? And you could see here that this greatest factor of 3 and 27, the biggest number that divides into them, is 3. So we factor out the 3. Now we see that they share an x in common. Whenever they share a variable in common, right, what we do is we factor out that variable and you take out the lowest degree. Here the lowest degree is 2. Here the lowest degree is 1. Therefore, you take out the lowest degree, which is the 1. All right, so now for our grand finale. Now let me focus in on these parentheses right here. All right, so how do I get that x plus 7? That's a question. So you're asking yourself, 3x times what gives you 3x squared? So we see that 3x times x. That's one way of thinking about it. Or you could take that 3x squared, let me use a different color here. You could take that 3x squared, and essentially what you're doing is you're dividing it by this 3x. That's another way of thinking about it. Divided by the 3x. So using our properties that we talked about earlier in this chapter, we reduce it, the 3's cancel, and you subtract your exponents, so you're just left with x. So that is where this x came from. So there's a couple ways of thinking about that. All right. Using that same logic, we ask ourselves 3 times what will give us the 27? Well, we know 3 times 9 gives us that 27. And then notice this 27 had an x, and so we need to include that x so that when we multiply 3x times 9, indeed that gives us the 27. So this is going to be our thinking when we are looking for the greatest common factor. All right. So what I want you to do is go ahead and try this problem right here. I want you to factor out this problem, and then we'll see what we get. So don't look at the answer yet. All right, so go ahead and press pause in this video. Try to factor this out, and then we'll see if you end up with the final answer. So go ahead and press pause. All right, so hopefully you had enough time to think about that. All right, so here we go. So I'm looking at 12 and 32. So I start with the coefficients, and I ask myself, what's the number, the biggest factor that they have in common? So what's the biggest number I could divide into 12 and 32? So hopefully you see that it's 4. So what I'm going to do is I'm going to first divide both of them by 4. Right, this is using one technique. And then I look at my next factor, which is the x's. So I look at these x's because that's what they both have. All right, so I have an x here and an x here. Remember what we say, we factor out the smallest degree. So we're just going to factor out 1x. All right, and then I look at the y's. They both have a y in common too. So I'm going to divide by y. But just like we said earlier, what is our smallest degree? Our smallest degree is 2. So that's why we're going to put y squared. All right. And what this is going to do, all right, let's see what happens here. Let's go ahead and simplify. So we have 12 divided by 4. That's going to give me the 3. And then the 32 divided by 4, that's going to give me the 8. All right, so let me write that down. I'll write it right underneath so we can see it. I'll actually write it right there. So we get the 3, and just like we stated earlier, when you simplify these exponents, right, these same bases, you subtract the exponents. So 2 minus the 1 is going to leave me just with x. And then we have y squared divided by y squared. These are going to cancel each other out. So we no longer have a y term. All right, we bring down the sign. We continue. 32 divided by 4, that's going to leave us with 8. In this case, these x's are going to cancel. And then here I have 3 y's, right? Y to the third power, y times y times y. Here I have y times y. So just using our properties, we subtract the exponents. So you're left with y. So when I look at how they got our answer here, remember what you're doing. This is your greatest common factor here on the outside. This is what they have in common, right? That's where this came from. This is what you divide by, what they have in common. And our result, right, this is what's left over. That's what goes in the parentheses here. So, and if you ever want to check your work, we just multiply. 4 times 3, that gives us the 12. That works out. 4 times 8, that gives us the original 32. X times x, that gives us the x squared. X times nothing here, there's no other x. That's where that x came from. Now let's distribute this to our 8. So we got x times no value here. We just have an x. You have a y squared times y, so you get y cubed. So all we're doing is distributing just to check to verify we get our original answer. All right, so this is the first thing we always check for when we're factoring. All right, so essentially we're just moving backwards here.